terms are same thing, functions or methods. In Java, we say methods. In the next semester, you'll have in C++. In C++, we say functions, right?
Yeah, my teacher mentioned going to C++ next semester.
Yeah. So next thing is what do you mean by function? Functions or methods is same thing in C, C++, Python, whatever language you are going to use in your life, computer language. Its meaning is same, right? So, function is a code snippet, and it solves some specific problems, and sometime it returns value, and sometime it returns value, and sometime it returns only the control. So function is basically a code snippet, and it solves some specific problems, and sometimes it returns value, and sometimes it returns only control to the caller. So it's like that. Fine. So it solves some specific problem, right? Okay. So best part is that so why we use functions, right? So we can call them multiple times. Fine. So why we use functions is why we use methods. So number one, we can call the methods multiple times. The code is reusable. So this term is very much important. Code reusability, right? Code is reusable, right? So we can call methods multiple times such that the code is reusable, right? And it divides a big problem, big or complex problem into many problems, small into many small problems, right? And by solving those small problems, we can can solve the complex problem. Fine. So this is why we use methods, right? So here the best part is the code is reusable. Once you have written the code, you can use it for multiple times. Evenly 1 crore of times you can use it. Evenly all through your life you can use that same code. Fine. So, and it basically the main purpose is it divides the big problem into small problems, and by solving those small problems we can solve the complex problem, right? So now you try to understand here one thing. There is in simple mathematics also how we use this, right? So you can think that a function is like a black box. Fine.
Okay.
A function or a method. Method is like a black box. Inside the black box, a machinery is fitted. Solve a problem, to solve our problem. So you can think that say you are in kitchen and you are cooking something, right? And now what happens? You need to grind something, right? Or you want to grind some spices. Okay. then you need to take a help, right? So what kind of machinery you needed? Correct. So you need a grinder, right? So you are not worried about the machinery inside the grinder, right? You are worried about, okay, how my spices are going to be grinded, right? So you put your spices in a grinder and grinder does its job, right? So methods are very much similar to like a grinder, right? So they are solving one specific problem, but your cooking is not done because you just grinded the spices. Now you have to put those spices in your cooking recipe, right? Understood? So cooking recipe is like an algorithm which you need to follow to cook something, right? Similarly, our programs are also like a cooking recipe. Fine. So, and we need to follow instructions according to that. Understood? So a method is like a black box. Fine. And inside a black box, a machinery is fitted to solve the problem. But as we are studying computer science, right? So we have to worry about this black box, right? And we are going to we are going to design this machinery. Fine. We are going to design this machinery to solve the problem. First, you try to use the machinery and then we try to solve how to build that machine. Fine. So that is what computer science. The people who don't study computer science, they are not worried about solving the machinery problem. But as we study computer science, we have to worry about that machinery problem also. Fine, because we are going to design everything. Okay. So let's see how it works. Fine. So in your math class, say you are in grade 8 or 7, you have seen something like this. Say f of x, right?
Yeah.
Which grade? 7 or 8?
Let's go 7.
7, right? So say f of x equal to, right? You have written x squared plus 2x and then you have written 4. Okay.
Okay.
So you can think about that. Okay, there is a machinery here. Let's design the machinery. It's black. Yeah, this is black. Okay. So this machinery is fitted in this box. I'm very bad in drawing, so just understand, huh? Okay. Okay. So let me. Okay, this is a box.
Yeah.
I need to attach this, right? And here f of x is there, right? So what we do here, we input our values, right? What we do, we input our values, and from here, we output our values. Okay, so you can think that, okay, this is a function, right? This is a function, right? And this one is called parameter. This one is called parameter of the function, right? And this whole formula which is present inside the machinery, right? This is called, you can think that this is the machinery. And this machinery will give you some output, right? So if you supply here 2, right? So what output you will get? You will get here 4 plus 4 plus 4, which is equal to 12, right? So if you supply here 2, right? What output you will get here? You will get here 12. Fine.
Yeah.
So it's pretty simple, right? It's a very simple machine. Okay. So let me give you another. You can take other values like 3. If you put 3, what values you are going to get here?
If I put what? 3,
Yeah.
I would get 9 plus 19.
9 plus 6. Yeah, correct. 19, right? 19. Right. So can you tell me the values which I am inserting, like 2, 3, 4, whatever values I'm inserting here, what these are called, if you remember?
Those are called. You've said they're part of the parameter.
Yeah, they are the parts of parameter. Means ki basically 2 I'm inserting in the parameter part, right? And these are input values. Basically, these are input values. What are these called in maths, if you remember?
The x values.
Yeah, the x values, right? Okay, not wasting time. So these are called domains, right?
Domain.
Yeah, remember this word is there, na? Right?
Yeah, domain.
So now your idea is clear regarding math also. So domain, right? So these values are called domain. And the values which you are getting as the output, these are called, I think so you remember the word now. These values are called range.
The range.
Right? So function always generates an ordered pair, ordered pair, right? So the first value is called domain and the second value is called range, right? So this is your input. So if you input 2, you will get 12, comma. If you input 3, you will get 19. Now, in this way, you can have multiple values, right?
Yes.
Okay. You understood this concept, right?
Yes.
Okay. So now I'm not going enter into this because otherwise this will be converted to math class instead of computer class. Fine. So
right.
So understood the concept of function, right? Even in maths also your conception will be a bit clear now. Fine. So the method is like a black box. Black box means that we can't see what is happening inside, and we are only worried about our output, right? So in grinder we are not worried about how the machinery works. We are only worried about our spices are going to be grind or not, right? So evenly sometimes we put some vegetables to grind also there. So that vegetable is grinding or not. We are only worried about that, the quality of grinding and all. Right? So method is like that. So now the conception regarding method is clear, right? Okay.
Right. Yeah.
Okay. Chalo then. The next thing. The next thing is. Yeah. So method is a black box, and inside the box, a machinery is fitted to solve our problem. In any programming language, methods are of 2 types. Right? You know the types of methods. Number 1
is there's a language type.
Right. User defined type. One is language type, and another one is user defined type. Right.
Yeah.
So we call it system defined. Right. We call it system defined. Defined type. Or the terminologies which you have used, language defined. And number 2 is user defined. User defined, right? So language defined is like the existing methods, the methods which are already existing in the system, right? Those are called system defined or language defined. So is system defined methods which is defined inside method which is already in the language, which is already defined in the language, right? Or present or defined in the language by the designer of the language. Defined methods. So, for example, in Java, we have methods like we have methods like system.out.print, right, which we have used, right? Or we have used system.out.println, right? We have used few methods like math.square root, right? Math.sqrt, or there are many functions like this present in Java, all right? And these methods help us to write our code, right? So these are existing methods or system defined methods. Fine. The next thing is user defined methods, all right? User defined methods. So the methods which is defined by the programmer, user defined methods. So the method which is defined by the programmer is called user defined methods. Okay. So the programmer has to follow the rules of language, define to define methods. So in this class, we are not going to study mostly system-defined methods. Because system-defined methods are already there, right? And whenever we need it, we can call it to solve our problems, right? But here today we are going to study mostly how to define user-defined methods, right? So we are concentrating on user-defined methods, right? So how to define user-defined methods? So basically, there are basically now we look at something like public, right? We look at this public static void. This is also a function, right? And this is a special user-defined function that is identified by JVM. Okay. So this is a method, right? So I'm going to explain you every word here, and by using these terminologies, I'm giving more gaps because I need to explain it to you. Because here the every terminology is important to define a method, right? So here we have something called public, right? Basically this is special function identified right, by JVM to start execution of code. Fine. So the first thing is public, right? Public is access specifier. Static is access modifier. This void is return type of method. Because what this method is going to return to the user or to the caller, right? This is function name or method name. This is parameter, right? This is called formal parameter. I'm coming in detail for every point. This is point number 1. This one is point number 2. This is point number 3. This is point number 4. This is point number 5. Okay. So I'm coming to every point one by one, right? So first one is access specifier. So access specifier or access specifier access specifier is the keyword which defines the access to the method, access to the method. Fine. There are 3 access. There are 4 access specifiers in Java. There are 4 access specifiers in Java. So let's write number 1. Number 1 is public. Number 1 is public, right? This access specifier means the method is accessible. Method has we can write the method has public access. Like public access, right? Public access means it can be accessible anywhere. It can be from anywhere. So this is the first access specifier. The second access specifier is private. The second access specifier is private. This access specifier states that the third is only used within the class. It is not accessible outside the class. Number 3 is protected. You have any idea regarding protected?
Protected? No.
Oh. This access specifier states that the method directly accessible.
1 second.
Within the package. But
Okay.
want to access. But if you want the access outside the package, then the programmer needs to create subclasses, right? So you heard about this term called subclass, right?
Yeah.
And you have not used it. Subclass is basically when a class inherits the properties of another class. So if it is outside the package, if you want to access the function outside the package, then you have to inherit the class, right? And then you can use it. Then you can use that method. Otherwise, it is not possible to use that method. Now, next thing is when you don't specify any keyword, right? In that case, the method is default access. Default. And when none of above words are applied, right? It means default access. The default access is only accessible within the package. Fine. So there are 4 types of access specifier, right? I hope the idea is clear to you.
I think it is.
Okay. Now the next point, point number 2. So next is number 2 is access modifier, right? Access modifier word static is used. Static is used when we want to access the method, access modifier keyword static is used when we want to access the method using class reference, using class reference. Using class reference, and we don't want to create, and we don't want to create object to access fine. So this is what static says, that when we want to access the method using class reference, in that case we create the static, right? So when we right click on any of the class of BlueJ, right? When we right click on the any class on BlueJ, what we will see that, right, when you right click on this, you will see that there are two options available here. One is new divide, right, to create the object, and you can directly call the method string args. So if we have written the method main, right, then we can directly call the method main using the class, right?
Right.
Okay. So that is what I'm saying here. Okay, access modifier keyword static is used when we want to access the method.
Mm.
You know, in this lockdown, I don't know why the friends always visits. Leave it. They went away. Chalo. So what happens? Access modifier keyword static is used when we want to access the method using class reference, and we don't want to create object to access the method. So the idea is clear, right?
Right.
When to use static. So when we want the class reference, then we use static. But static methods can be called using objects also, right? So I'm writing here the static methods, the static method can be called using objects also, using objects. Another point about static method, that static method control I static method you will understand this point after a week or like that. Static method never uses the instance variable. Variable. Way it can use static variable of the class. Variable of the class. Understand this point after, when I will teach you class and objects, right? I've not done class and objects with you. Later, means after this class, the next class I am doing the class and object. I will make you understand. In that time, you will understand this point. Static method never uses instance variable. It can use static variable of the class, right? So if you try to access instance variable from the static function, the compiler will give you left and right. It will give you an error. A left and right means error. Okay, so the compiler will give you an error, right? In that sense, it will show that you are trying to use instance variable, which is not allowed from the static member function. Okay. Right. So this is the story behind access modifier static. Okay, this is the total concept regarding that. The next thing is you have to write a return type. Next thing is return type. Type. Return type of method. Sometimes our method, methods are supposed to return values. Supposed to return values, right? Depending upon what kind of computation it does, what kind of computation it does, right? So methods are supposed to return values depending upon what kind of computation it does, right? If the method is doing, if the method is solving integer problems, it will return int value. It will return int value, right? If it is solving decimal problem will return double or float, then it should return on double or float, right? And sometime double or float, and sometime the method is solving some action, returning any value, but not returning any value. Then we have to write void as return type. Fine. So understood the purpose of return type of a method. So methods are supposed to return values depending upon what kind of computation it does, right? And if the method is solving integer problem, it should return integer value. If it is solving decimal problem, then it should return double or float. I'm not written all the types. So character, sometimes it returns character, sometimes it returns objects also, right? Sometimes the method is solving some action but not returning any value, then we have to write void as a return type, right? So we have used one method called system.out.print or system.out.println. It never returns a value, right? It does an action because it prints the value present inside the parameter, right? So whatever value we are passing into the parameter, that value is printed on our terminal. So in that case, system.out.println is not returning any value. That means the return type is void for it. Okay. So that is the return type of the method, right? The next point is function name. So function name, any type of computation, we can give a logical name to it such that we can easily identify what the method is doing, right? So that is why we always give a logical name to it, right? So as that we can easily identify what the method is doing, right? Then while naming the method we need to follow identifier naming rules, all right? You remember what is identifier naming rules? It is taught in last semester.
Identifier naming rules.
Or the naming rules for variable names.
For,
It always starts from
A.
It always starts from alphabet,
Right.
because the name always starts from alphabet. No, it's very simple thing. So that will be easy to recognize something, right? Say for example, if your parents have given you a name like 475, then it will be very much difficult now if everyone is giving numbers as a name, right? Then it's very much difficult to identify a person. Okay, which number person? No, and sometimes number matches also. Okay, so that is why we start always function name with an alphabet, right? So for example, your name is Uday. So the Uday we can easily identify. If we call Uday, U comes, right? So that is why we give logical names to a function, right? And it actually the name. Say for example, we are adding numbers. So we have given a name to a function called add, right? And we are adding two numbers with the add function. But if we are subtracting two numbers and if we have given the name add, then so it is a problem, right? So we have to give a logical name to our functions, right? And we need to follow the identifier naming rules. It is there in your book also, Java for Everyone, right? Just read it. You have PDF of Java for Everyone?
PDF of. I have a no, but I think I have an ebook version of it.
Yeah, if you have ebook version of it or a PDF, then you can perform a search, identify naming rules. So automatically you will get the page and you can read that rule.
Actually, wait, I don't have that book. I have something else called Java Concepts, Late Objects.
Java Concepts.
Late Objects by K.S. Horseman.
Okay. Java Concepts Late Object. Okay. You have the PDF of it?
The ebook version of it, like I said.
Yeah. Okay. Fine. Can you share this book with me?
I can tell you where you could download it.
Okay.
So look up. Let me see if I could like type it in or something. BlueJIS.
libgen.is.
Yeah.
Okay. Let me type libgen.is.
Yeah.
Okay, and here I can type.
Yeah.
Say what's the name of the author?
K.S. Horseman.
K. Oh, spelling is correct, right?
Let me see. Yeah. Yeah, just add another N at the end.
Man. Okay. Okay. So he has written many books. The name of the book
is Java Concepts Late Objects.
Java Concepts Lead Objects.
Let me see if I can find it and put a link.
Oh yeah, I'll check it. Okay. Yeah, I got it.
Okay. And then what you do next is you click on a number in one of the mirrors and you'll be able to download a version of it.
Okay. Big Java Late Objects it's called.
No. It's just Java Concepts Late Objects.
Okay. Java Concepts Late Object. There is one Big Java Early Objects. Yeah, Java Concepts Early Object is there.
Let me just send a link and see. And I'm pretty sure you could just click on it.
Okay. Yeah.
And then in mirrors, you can just click one of the links.
Okay, so let me click the first link.
And then just click get.
Okay. Okay.
So yeah, this version, the first one is a PDF. It's not my version, but it's close enough. The only thing you'll be missing out on is interactable exercises.
Okay, maybe. Okay, let me download this. Books. Java books. Save this. Yeah. This website is from Russia.
It works though. I have saved over at least $300 when one of my friends told me about it.
Okay, this is the book.
Yeah.
Okay. Fine. Nice picture of animals.
Yeah, that one was pretty weird first time I saw it.
Okay. At least one signature is invalid. Okay. Signature panel. Fine. All right. So you can perform a search over here by using this. and you can write here identifier naming rules. You click on next. Yeah, variables, right? Okay. So here you have something called variable declaration. No, number types and all. Yeah, variable names, right? And here you can see that. Let me cancel this out. I know that array. It went away. In chapter 2.
Yeah, I'm on it.
Yeah. In chapter 2, you click on variables, and you can see that variable names, right? So let me increase a bit of percentage here. 75. Okay, now you can see that when you declare a variable, you should pick a name that explains its purpose, right? For example, it is better to use descriptive names such as can volume than a terse name such as CV. In Java, there are few simple rules for variable names, right? So you can go through it and you can understand. The same rule applies for method name, right? And the same rule applies for class name also. Okay, so you cannot start with numbers or like that. So if you know this rule, you can easily define the class name, the method name, right, the variable name, right? There are 4 rules and you just need to follow these rules. Okay, and we use here camel case because camel case is basically camel have humps, right? So we start with a small letter and the next word is capital, starts with a capital letter and the next word is again capital letter. So that is why it is called a camel case, right? And that's a very good convention used by programmers to identify the identifier names, right, or the variable names. Okay. So you just go through this, then your basic conception will be clear. I'm teaching you because I have very less time to teach you. So I have skipped many things here, right? You just go through this, right? You just go through this. I'm teaching you chapter number 5, basically. Okay. Chapter number 5. After that, I can go next class. I will be going. Maybe I will be continuing with this, and I will be teaching you arrays also.
Okay.
Fine. So because I have to go to faster way, because if your next semester start, because I need to finish it by May, June, this course, I'm trying to finish the whole book by May and June, such that when your next year course starts, so you will feel comfortable. All right. So okay. I'm teaching you a bit of faster way, and you just go through with your book, and whatever you needs to ask me, you can ask me, sir, I didn't understood this part. So I will explain you that. Fine.
Okay.
Okay.
Yeah. So, just 1 second. I gotta go wash my hands real quick.
Okay.
Got something weird. Okay, I'm back.
Okay, sure. Then we continue with the functions. So that is what about function name, right? So I'm just writing in the bracket. Use your textbook to read about the rules. So the next thing is, the next concept is 1, 2, 3, 4, fifth one. Formal parameters are a list of variables present in the parentheses of the method. You understand the word parenthesis, right?
Yeah.
Okay. It's a round bracket, right?
Yeah.
The math teacher used to write round bracket, the square bracket, and the curly bracket, right? But it has a name. It is not a round bracket. It is basically a name called parenthesis. That is a square brace, and the other one is a curly brace, right? So formal parameters are the list of variables present in the parentheses of a method prototype. This whole thing, this whole thing, let me this whole thing is present, right? And this whole thing is called method prototype. Right? This whole concept is called method prototype, right? So this is concept number 6. So I will explain you what is a method prototype also after this. So the whole stuff, you can see that the rectangle, right, which is containing a public static void main string args, the whole line is called method prototype, right? So a method present in the parenthesis of method prototype is called, so is a formal parameter, right? Is a formal parameter. It receives values from its caller, right? And uses these values to compute, uses these values to process and compute useful information. All right. Okay. So this is how a formal parameter is used. It receives the value from its caller, right? Understood. So formal parameters are the variables which receives values from its caller, right? So next thing is number 6, function prototype. Prototype. This it is basically defines the method. It is basically defines a method heading and the rules for people who are going to use this method, this method. future. Fine. This is what prototype, right? It consists of access modifier, access specifier, access modifier, return type, method name, return type, method name, parameter list, right? So this is what is called function prototype. So your function is already defined. Say for example, we have defined a method. So for example, we have defined a method. We have defined a method called say we have defined a method say integer of add integer of x comma integer of y. Fine. So this is the method prototype, right? So here this x and y, sorry, here, yeah, here this x and this y is formal parameter, which receives the value, right? Which receives the value, right? And this whole thing is called, you can imagine I've not written any access specifier. This is a default access method, right? So this whole thing is called function prototype. This whole thing is called function prototype. This whole thing is called function prototype. Fine. Achha, now what I have to do, now there is another concept called I have to call this function. I have to call this function. Then what I have to do, I have to write here integer. So here integer of s equal to, right? I want to add the two values. So I have to write here add, and I have to write here two values, say 10 and say I've written here 15. So if I write the statement like this here, system dot out dot print here /n, and I write here s sum equal to, and if I write here plus s, then it will print the value 25. Then what it will print? It will print the value 25. And it will print the value, and it will print sum equal to 25. Got my point? So what is happening here? There is a concept out here, right? So this stuff is called function signature. What it is called?
A function signature.
Right? So in function signature, we pass the values depending upon the number of parameters or the number of formal parameters are there in the function prototype, right? So this 10 will copy it to this x, this 10 will copy it to this x, and this 15 is copied to this y. But my point, this 15 is copied to y, and the add function will perform its computation process and returns a value. Fine. So so this is how it works. So this concept is there also, function signature. So let me write about function signature also here. So it is used to call a method by passing arguments, arguments. This is important, arguments or actual parameter, passing arguments or actual parameter, right? it is used to call the method by passing arguments or actual parameter. Okay. So this is called function signature, right? And it consists of function name, and actual parameters to call a method, right? So here these two, this 10 and 15, all right? Here these two, the 10 and 15, right? These two are what? These two are actual parameter. These two are
the actual parameter.
Yeah, actual parameter. Fine. So this is the basics of functions, right? There's nothing out there. I have covered every topic. Okay. Now the next thing about function, very important thing called return statement. Control return statement. Okay. A return statement. Right. So this is another important topic which we are going to study. A return statement. So yeah. So return statement, the return statement meant returns the control to the caller and exits the function Fine. So while returning the control, right, it carries a single value to the caller. It sometimes carries a single value to a function, right? To the caller, in a method only once the statement executes. The return statement executes. But we can use it multiple places. Depending upon our need, right? So this line I've written because many people got confused. I have to use only one return statement. That is not the case. The case is this: you can use a multiple return statement. Out of those only one will execute. evenly the add function have only one return statement written inside it. Fine. But there are many situations where you can use multiple return statement. Fine. So there are three types of uses of return statement. Fine. So a return statement used in three ways. Fine. So number one is a return semicolon. So this is the first way, return semicolon, right? It means the method return type is void, right? And we want to stop the method, right? We want to stop the execution of the method as the action is performed, by the method, right? So this is how we use a return, right? This is one way. And perform the we want to stop the execution of the method. The action is performed by the method, and the control and the execution control. The execution control will be returned by the method. Okay. Got the point?
Yeah, I think so.
Okay. Number two, return, and here return, and here we specify some value. Right? So here in this use we are specifying the specifying the value or the variable of return type of the method. In this use, we are specifying the value or variable of return type of the method. Fine. So the return type here, the value depends upon the return type of the method. The return type is int, the value is of integer type, right? Or the variable is of integer type, and that value is going to return to the caller, right? So in this use, we are specifying the value or the variable of the return type of the method, and this value and this value is returned to the, and this value is returned to the caller, right? And method is exited, and the method is exited. Okay. So this is number two. Now number three, return, and inside the bracket, inside this bracket we have written one test expression, here, right? Or Boolean value, or Boolean value, fine. So in this use we are specifying the Boolean value or test expression which results into Boolean, Now this type of return statement used with methods which return Boolean value. So this is the story regarding return statement. So whenever we are solving our problem with functions, so these conceptions are required, right? So user-defined functions. Okay. User-defined functions are of two types, right? So number one is user-defined functions can be called in two ways. Right? So number one is call by value, right? And number two is call by reference. So we study call by reference for 1 week, and in the next week we study call by value. Sorry, first we study call by value. Today I'm going to teach whatever functions I will write today that is actually call by value. Fine. And the next day we will be studying call by reference. Fine. I will teach you call by reference while teaching classes and object. Fine.
Okay.
So whatever functions generally we use is call by value. So I'm going to give you the idea regarding call by value first. Okay. By value. So control V. In this type of call, the methods copy the actual parameter values into formal parameter, and then the function, or method, then the function or method perform its computation or action, right? and then the function or method perform its computation or action by using these methods, by using these values, by using these values. So the values, the data, so the data present in the caller method, will not get affected, by these operations, by these. So in call by value, the original variable have no effect, right? Have no effect. Fine, their values will not get affected, right? So it is like a Xerox copy of a original copy, and in Xerox copy you are using your pen, pencil, everything. Okay, so the call by value method will not put any effect on the actual parameter variables, right? Because they are supplying the values to the formal parameter, and formal parameter using the copy of the value and performing its task, right? Or performing its computation or action by using these values. Okay, so this is the idea behind the call by value. Okay, so I'm showing you one function today, and this topic will continue. It's a big topic, so it will continue for 2-3 weeks. Fine. So I'm showing you today one topic, and I will be giving you some problems. That is not, you don't have to use functions to solve those problems. You have to use nested loops to solve those problems, right? So this week also you practice about loops, about nested loops also. Okay.
Nested loops.
Sure. You have not done nested loops, right? So this week you are going to use the nested loops. Fine. So in this type of, so let me show you. Let me show you. Oh boy. Let me show you. Let me show you some example of call by value, right? Or functions, how we can use it. Fine. So yeah. So new class, and I'm checking number is a prime or not, right? So say number theory. Name of the class is number theory, and in this class I'm writing a method yotel.star. Static void RGS. Fine. Then here what we are doing, say we are supposed to print all the prime numbers from the user will specify the start value and the end value, right? And we are going to print all the prime numbers from the start to end. So how to solve that problem? Okay, so that is what we are doing. We are going to do here, right? So let me function like public void print or print primes, print primes, and here I'm writing int start, right, and int end. Okay, and then I'm creating a loop here for semicolon start is less than equal to end, right? And I'm writing here start plus, and then I'm writing here system dot out dot print start. So I need to check that key start is a prime or not. Fine. So we have written here if start is prime, if is prime. So is prime is a function, right? Is prime is a function, and I'm passing start here. Okay, closing this bracket. Fine. And this is prime function. If the function is returns, if this function is prime function returns true to me, right? Then I will print the value of start. Otherwise, I will not print the value of start. Here I'm writing public boolean because I need to return true or false. So I'm writing here public boolean is prime. And I'm writing here integer of x. So this x is a formal parameter, and this x is going to receive the value of start in it, right? And it will test that x is prime or not, right? So this is one independent unit, right? So I'm writing here return true. I'm assuming that the number is prime, but I need to test whether the number is prime or not, right? So I'm writing one another way of the prime number logic like that key. It's the number which is divisible by 1 and itself, right? So if I I'm writing a logic in a different way, okay? And this is one of the most optimized logic available in the market, right? So I'm writing here if x is not equal to, or if I'm just writing x is greater than 2, right? Is greater than 2 and x modulus of 2 equal to 0, right? Fine. Or I don't want to test negative numbers or 1 for the prime number. So I've written here x is less than 2, right? So if this is a situation, now if this is a situation, I will return false. I will return false. Means key it is not a prime number. Return false. Because my program will not work for any negative number. It will always work for positive numbers, right? And if the number is 2, so 2 is a prime number, right? So that 2 is not going to be checked over here, because if the value of x is 2, so 2 is greater than 2 is false, right? So this part of the bracket is resulting false, and 2 is less than 2 is also false. So this if test is failing, so it will not execute its body, right? So it will go to the next line after this curly brace, over here. So here I'm declaring a for loop, right? And in this for loop, I'm going to declare a variable which is going to divide the number. So now all the even numbers are solved. So whatever even number you will input, the first condition will make it false. Say if you input 38, so 38 is greater than 2 and 38 modulus of 2 is 0, so it will return false. It will not execute inside the loop and go 38 times and then it will say, okay, yeah, this number is not a prime number, right? So it's very fast, right? This logic is very fast. Now it's solving the problem in a very fast manner. Fine. So,
Yeah.
okay. Now the value of D is, so now we are left with odd numbers. We are left with odd numbers,
Odd numbers.
right? So what is an odd numbers are generally divisible by odd numbers, right?
Yeah.
So 9 is divisible by 3, 49 is divisible by 7. Understood? And
Yeah.
25 is divisible by 5. Okay. So I am starting the loop with the odd number, right? So first odd number is 3 after 1, right? 1 is useless for us. So 3. So now I'm writing here I is less than equal to math dot sqrt, right? So here also I'm optimizing it because I'm not going through all the numbers, right? So if you do square root, so the things is already optimized. So if there is an odd number and that odd number is divisible by 3 to square root of that number, if the divisor is present, then that number is not a prime number. Fine. Then that number is not a prime number. Fine. So this process is also faster. Fine. Because it will not going through all the numbers. It will not going, the loop is not going through all the numbers. It is skipping the numbers. Fine. So square root of x. So you write here d. So odd numbers I have to generate. So d plus equal to 2. So I'm generating odd numbers, right? So now in the for block, what I will do here, I have not written this. So in the for block, I've written I instead of D. For block, I will write if x modulus of D is double equal to 0. Then what I will do, I will return false. Return false, right? And how many times I've used return? 3 times, but only one return will work. Got my point? Either this return will work, or this return will work, or this return will work, right? So say for example, you have entered here 29. The value of x is 29. So this condition is false. This whole condition is false if it is 29, right?
Yeah.
Now it will enter over here. So the value of D is 3. Fine. And D is less than equal to math.sqrt of x. So what is the square root of 29?
The square root of 29 is...
It's 5 point something.
Yeah.
Okay. So let's take it 5. Let's take it 5. So now x modulus of D. So 29 modulus of 3. How much?
Modulus 3 is...
Oh, 3 9s are 27. So 29 minus 27 is 2. So which is not equal to 0, right? So this condition is also false. So it will jump back to this part, right? D plus equal to 2, right? So the value of D will become 5. Okay?
Yeah.
Okay. Now 5 is less than equal to 5.
5 is less than equal to 5. Yes.
Yes. Now you are here. Okay. So x modulus of D. So 29 modulus of 5. How much?
You said 25 modulus 5?
5, yeah.
0.
Oh, 25 modulus of 20. It's not 25. The value of x is 29.
Oh, it's divided. Modulus 5 is 4.
4, right? Which is not equal to 0. So now you just directly from here to here. So the value of D will become. So the value of D will be how much?
The value of D will
Earlier
be...
it was 5. So now it will be
Earlier it was 5. Returning it would be 7.
7, right? 7. So 7 is less than equal to 5 point something, right? So condition is false. Correct?
Right.
Now when this condition is false, so control will come down to which part? Control will come down to this part, right? Control will come down to this part. So it will return true. It will return true. So 29 is a prime number. Okay. So you can imagine how many steps this for loop has executed. This for loop has executed only 3 steps, 3, 5 and 7. It's executed only 3 steps, 3, 5 and 7, right? And plus it has tested this condition once, right? So how many steps are required to solve, to say that 29 is a prime number? Only 4 steps. Only
4 steps.
We can say that 29, our computer says that 29 is not a prime number, right? And the logic which you are using earlier, it will take 29 steps to say that number is a prime or not. Right?
Right.
Because you are using for integer of I is equal to 1, I is less than equal to x, I plus plus, and then you are testing if x modulus of I equal to 0, then you are counting C plus plus key how many times the number is dividing, right? So you have executed the for loop for 29 times, and then you are coming out of the loop, and then you are testing if C equal to 2, then you are returning true, otherwise you are returning false, right? Right. So in that way you are solving your problem. So what is happening? You are using 30 steps basically for 29. So number plus 1 step, right? So but here how many steps is needed in this logic? 4 steps. So it is very much optimized, no? And if the number is even also, say the number is 28, right? So number of steps needed in your code is 29, right? And the number of steps in my code, only 1. Only 1, because 28 modulus of 2 is 0. So return false is directly says it is not a prime number. So this code is smarter, right?
Yes.
Right. So you need to think about this in your life, right?
Right.
So you have to write smart code.
Smart code.
All right. So you have to write smart code, but don't try smart code in college or school. Fine, because if the teacher don't understand, they will deduct marks.
Right.
So whatever they are teaching, just use that. You respect the teachers, but in real life, the smart codes are very much useful, because you need to outperform, your app is supposed to outperform the other apps, because the competition is very high. Fine?
Yeah.
So this is what you are going to do. So let me execute this code and show you the execution stepwise, right? So what you can do, how to execute the code stepwise, you click on this line like this. I've compiled the code and I click this line. This is something called stop came, right?
Right.
Okay. So I want to stop at this line. Okay. So I'm compiling this code. I've not written the main function here. So what I have to do, I have to create the object of this code. Okay. So I created the object of this code on the object bench. So this object is created. Now right click on this object. Okay. You will find that there are two functions here, right? Boolean is prime int x and Boolean print prime int start and int end. But I want to execute Boolean is prime. So I clicked on Boolean is prime int x, right? So now it is asking for the value of x, right?
Right.
So say I'm entering 29. Okay. So I have entered OK here. Now you will find that in debugger, right? There is a debugger key. Okay. So what you can do here, so you can use a debugger, and you can see that your this is your code editor is also active. Or code editor is also active, right? And you can see in the debugger, right? So now you can see the value of x, which is 29, which I have entered here. So this condition is also false. This condition is also false. That is why you can see that the green line is there. Okay. Now what you can do here, now when you click on step, only one step of for loop is executed. Now you will see the local variables here. Concentrate on here. You will find that D will be created and its value will be 3, right? So I clicked on step, and you can see that the green, you follow the green line. So the value of D is how much?
The value of D is with the break or the stop thing put.
Yeah, definitely. You just see the debugger. It's there.
I can't see this. Oh, never mind. I can see the whole thing. When I full screen it, it's 3.
Yeah, it's 3, right? So now I will execute x modulus of D, right? So this condition is true or false?
This condition is x29. False.
False, right? So I'm going to click on step, so it will go to the for loop back, right? So I clicked on step, so it went to the for loop. Now it will update the value of D plus equal to 2, which is 5, right? And 5 is less than equal to math.sqrt of x, which is 5 point something. So the condition will become true now, right? Now when I click on the step, these two steps will follow, right? You see that the value of D is the value of D is 5. You see this? The value of D is 5.
Yeah.
Don't type your code or something, whatever you are doing. Just concentrate on your screen. Whatever I'm doing, it will be there with you. Okay. Don't worry about this. I will send the OneNote to you, and I will give this code to you also. Just follow the instructions, right?
Okay.
So integer of x is equal to 29, fine. And and integer of D is 5 now, right? So 29 modulus of 5 is?
29 modulus of 5 is 4.
4, right? So 4 is equal to 0 is false, right? So when I will click step, right, then it will jump to the for loop. It will jump to the for loop again, right? So now it will update the value of D first. So the value of D will become 7, right? And 7 is less than equal to 5 point something, right? So condition is false.
Yes.
So condition is false. So when the condition is false, it will go to return true, right? So when I click on step, it will jump to return true. See the green line. Okay, I'm clicking the step. So I click the step, it jumped to the green line, return true. So now it is going to return me when I click on step, right? It's going to return me true, right? I clicked on step. Now you will see it is returning me. What it is returning? It is returning me true. It is returning me true, right?
Right.
Got how I am working with it, and how you can, how you can whenever you are in trouble, how you can test your code line by line.
Think so.
Okay, so this is how you can use the debugger in BlueJ. Fine. I will show you how to use debugger in Eclipse also, but that thing is a bit complex for right now for you. So after 2-3 weeks, I will teach you how to do that in Eclipse also. Fine. So it's very much easy to learn the technique, right? Over here, and you can improve your logic. Fine. So it's solving our problem. Fine.
Yeah.
Okay. Now if I let me do another experiment. Let me try some number like let me try some number like 48. So 48 is not a prime number. It is an even number. Fine. So it will take one step, I've said. So now you see. Okay, it's showing me what it is showing me. It's showing me
Showing false.
Right. Okay. And then what happened to this one? Yep. What happened to this one? Okay. So let me terminate this. Okay. So let me create another again an object, and again I'm using a number like 57. No, not 57. Let's use 49. So 49 is a prime number or not?
Yeah, I think so. It is, I believe.
So 49 is divided by 7. So it's not a prime number. Okay.
Right.
So x is, what is x? X is 49.
49.
Right? So because it needs more step, so that is why because I stopped here now, I stopped the code here in the debugger, so that is why it stopped here. Earlier it won't stop because it is solved over here, because when I've given 48, so 48 is solving in one step, so it didn't stop, right? So when I've given x is equal to 49, then it has stopped over here. Now the square root of 49 is 7. So my loop will execute for 3, then 5, then 7, right? Now you see in 3 steps I can say that 49 is not a prime number. Now you see the steps. Now the value of d is 3. So 49 modulus of 3 is not equal to 0. So the condition is false. So d plus equal to 2 will happen, right? So d plus equal to 2 is 5. So 5 is less than equal to 7. So this loop will execute once more. So 49 modulus of 5 is 4. So 4 is not equal to 0. So now when I press step, it will go back to the for loop. So it will increment the value of d. So the value of d will become 7. So 7 is less than equal to 7 is true. So it will enter again over here. So 49 modulus of 7 is 0. So it will return false because this condition will become true. So now it will return me false. Right?
Right.
So how many steps are needed? 3 steps. 3 steps. Sorry, actually 4 steps, because that if condition is also executed, but it is false. That is why it enter into the for loop, and for loop condition is tested for 3 times. Right? So how many steps are needed? Only 4. In 4 steps we can say that 49 is not a prime number. Understood? Right? So now let me show you another thing here. So just a minute. Let's open the code wala part. Yeah. Let me remove this stop option here, because if I give the bigger range, that it will be a problematic for us. So now what I'm doing here, I am executing print primes. So I have to supply 2 values here, right? So what I can do here, I have written here 100 and I have written here 200. I want to print all the prime numbers between 100 and 200. So let's see how many numbers it will print. So it has printed, right? 101 is prime number, 103 is prime number, 107 is prime number, 109 is prime number, 113 is prime number, 127 is prime number, 131 is prime number, 137 is prime number, 139, 149, 151, 157, 163, 167, 173, 179, 181, 191, 193, 197, and 199. All these numbers are prime numbers, right? So we solved one complex problem using functions, right? Okay, I'm not going to give you any exercise on functions. I'm going to give you exercise on nested loops, right? So you give a try, and if your try is not working with the nested loop, I'll take a small class tomorrow for say 30 minutes. Okay. Okay. So today I'm going to give you some nested looping problems. In few minutes I'm going to give it to you. Okay. So you try to do those and you read the notes first. You go through the notes. You see this video again. All right. I'm uploading this video on YouTube also. You see this video again. Fine. And read the notes clearly, and I'm going to give you the nested looping problems. And next day again we continue with the functions. I will show you how to use functions, right, in your code, because that is more important than theory. So but theory also you will read it. Clear?
Yeah.
So I'm copying this and then I'm pasting it over here. So these are the output, and here I will paste the code. There's a code here. There's a terminal window. This is the debugger. This is the code here. This is the code, right? And this is wait, testing for X as name or not. And providing start and end values to print all the prime numbers, between start. And here method is prime is called, but its prime is called, which returns Boolean value. So this is the code. I've pasted it over here. You can try it in your computer by copying and pasting it, and you can try the debugger also. You practice with the debugger also, right? So debuggers are quite it's a very useful tool for the coders, right? You have to know how to use a debugger. Okay, fine. So
yeah, I got it.
Okay, I will send you the